Hi General Math students, in this video we're going to look at residual plots and we're going to discuss the features that we use to determine whether or not a model is well suited to the data, and we're going to use the residual plot to do that. Now just a quick bit of background here. What are residuals? So it's explained here, and you could pause the video and read this, but I'll just give a quick explanation. For instance, they've identified this particular point here. I'll just zoom in a bit, this point here, and that we have this gap being shown here. In fact, I'll switch to a different colour, I'll go red. So that gap between the line of best fit and this data point. So it's showing us the difference between the predicted value, which is on the line of best fit, and the actual data point. And that distance there that I've just marked in red is identical to the distance on the residual plot. And for instance, if we were to look at this point up here, this second last data point, you can see that it's up above the line of best fit, and the residual is shown there. That distance is the same on the scatter plot as on the residual plot. So it's showing us the distance or difference that between the data points and the line of best fit itself. You could even think of it that in this way, that the line of best fit becomes the x-axis in, in the residual plot. So it's like that line of best fit is transferred across as an x-axis in that residual plot. So the residuals are showing us how far the data points lie from the line of best fit. And that's important to determine whether or not the model is appropriate for the data. So let's look at an example. Okay, so we've got a scatter plot here and the residual plot next to it. In order to obtain a residual plot, you'll need to watch or to learn how to obtain a residual plot using the calculator, you'll need to watch a different video. We're just going to discuss how to interpret the residual plot here. So, when we look at a residual plot, we're looking for certain features. I'm going to write them down here. So, the features that indicate whether a model is appropriate for data. First off, we want to look for a random distribution of points. And that's in the residual plot itself, this one here. So we want there to be no pattern. Okay. Now, another thing we look for is same number of data points above and below the x-axis or the horizontal axis. So what we're talking about here is positive points or positive residuals should be equal to the number of negative residuals. So for instance, we count all the positive residuals up here. We've got 1, 2, 3, that one's just positive, maybe that one 2, and maybe that one as well is just positive. They're sort of sitting on the line but just up a little bit, so they're most likely positive. These ones are all negative, sitting just down below the line. Okay, so we want the same number of each. We want this, or similar, as close to the same number as we could get. Ideally exactly the same number above and below that horizontal axis. Now, the next thing we're looking for is an even horizontal band. I'll explain what that means when we look further at this residual plot above. And the last one, which is often the hardest to judge, especially when you're learning this material and unfamiliar with it, we're looking for small residuals. And that's in comparison to the Y data. So I'll elaborate particularly on these last 2 points more when we look closely and interpret this residual plot, which we'll do right now, in fact. Okay, so random distribution of points, no pattern. This residual plot certainly has that. The points appear to be randomly scattered. So why is that important? Well, often a pattern in the residual plot, and we're talking about a pattern like this one down below where there's a bit of a smiley face, or sometimes you might have a residual plot where rather than a smiley face you get a sad face. So that's the sort of pattern that we're trying to avoid, is those curves to the residual plot. The reason for that is because most likely what's happened is that non-linear data is being modelled with a straight line or a linear regression. So a pattern like this in the residual plot indicates that you're putting a linear relationship onto non-linear data. So we much prefer something randomly scattered like this one up the top here, because it shows that the data points are just following along with the line. They might not be exactly on the line, but they are following along the line in a linear type fashion. So for this residual plot here, we certainly can tick that box. There's no obvious pattern there. Now, same number of data points above and below the horizontal axis. Okay, now I circled some before, but I haven't counted them yet. We've got 1, 2, 3, 4, 5, 6 above, and we've got 1, 2, 3, 4, 5, 6 below. Now, I haven't done anything with this one here. I find that hard to tell whether or not that's on the above or below or exactly on the horizontal axis. But in the end, it kind of doesn't matter if you think about it, because we've got an odd number of points here. So if there's an odd number of points, then it's not really possible to have the same number above and below. But if we sort of consider this point here to be right on the line, then we certainly have an even number above and below the x-axis, and that's about as close as we can get. So I'm going to say we've ticked that box as well. So far, this is looking like a good residual plot, or a residual plot that indicates a good model, rather. Now, why is that important, the same number of points above and below the horizontal axis? Well, one case we could look at is the case of there being an outlier. All right, this outlier here. And you can see that in this case, there's a bunch of points that are below the line and one data point above. So having too many on one side or the other could indicate an outlier. So a data point that maybe there was a mistake when they recorded that point, or something of that nature. So that can indicate an outlier, which is why we look for that particular feature in a residual plot. Okay, even horizontal band. What do I mean by this? Right, I'm going to draw a horizontal line through the biggest positive residual. So those are these ones here, they're about the same. And through the biggest negative residual. And when we do that, we want the distance to be about the same from the horizontal axis in the positive direction and in the negative direction. Now they're relatively the same. There's not a huge discrepancy between those two. So this looks like an even horizontal band. And it's for a similar reason as before, with the same number of points being above and below the x-axis. You can see that this outlier has created a situation where there's quite a bigger, it's not really an even horizontal band because it's skewed upwards, much bigger gap. So once again, could indicate outliers, and so we don't like that. That doesn't indicate a good model. So let's tick that box as well. We have a relatively even horizontal band. So we'll tick that box. Okay, the last thing we're looking for is small residuals in comparison to Y data. Now, in this case, the Y data is this data on this axis here, the fuel in litres per 100 kilometres. Now this is the trickiest to judge, and I'll just give you a little bit of an idea of how we could do it in this situation. Let's look for what is around about the largest residual, the largest in magnitude or size, and it's probably this one here, isn't it, that one? It's at about negative 0.9 or negative 0.8. It's slightly bigger than these residuals up here. So let's just record that. Our largest residual is of magnitude about 0.9 or negative 0.9. So largest residual, oops. Is, I'll just say approximately equal to negative 0.9. It's hard to tell with that graph, but round about that value. All right, now let's look at the Y data. We can sort of estimate here that it goes, the biggest ones are at about 18 litres per 100 kilometres, and this one here, what have we got here, 5, 10, so that's probably about 7. So it ranges in size from about 7 to 18. Now I would consider 0.9 to be pretty small compared to these two numbers. We're looking for somewhere around 10%, So it's getting down to a pretty small number. So I think in this case we can say small residuals. Now that's just something that with experience you'll get a feel for. And if you're really not sure, you better talk to your teacher about how to judge that one. But often these questions, we make it quite obvious that the residuals are pretty small compared to the Y variable data. Okay, so go ahead and check the description of the video to see which questions you should try. Oh, and don't forget there is actually, before you do that, there is another video in which we're going to continue this example in part 2. So I'll stop there for now, and yeah, before you go and try those questions, let's try the next video in which we'll continue this example. But overall, this model is appearing to be a good model for the data based on the residual analysis. Thanks for watching.